Let's break down how to read an OTDR curve, super useful for fiber optic pros. The OTDR curve shows how signal loss is distributed along the fiber. As seen in this optical fiber segment, the curve slopes downward, continuously. Since fiber is continuous and uniform, you'll see steady loss like this section here, which indicates that there is constant loss throughout the fiber. There are two event nodes, event 2 and event 3, in the middle. Event nodes usually represent fusion splicing points, or connection points of the optical fiber. A downward drop like this is generally a fusion splicing event, while a reflective peak like this is typically a reflection event, which corresponds to a connector flange. There is an event list below the graph. From this list, you can check the positions of the corresponding event nodes, as well as parameters such as the loss at those nodes, the length of the broken fiber segment if any, the loss of the fiber segment, and the attenuation coefficient. All these can be found in the event list below the curve on the instrument. For the same optical fiber, when tested at a wavelength of 1550 nanometers, the measured curve of the fiber is relatively smooth. However, when tested at 1310 nanometers, the curve of the same fiber has a steeper slope. This is because the average attenuation coefficient at 1310 nanometers is approximately 0.33 dB or km, while that at 1550 nanometers is about 0.2 dB or km. Therefore, the attenuation of the same optical fiber at 1310 nanometers is greater than that at 1550 nanometers. Curve theory covered. Let's move to hands-on tests and common curve scenarios in daily use. For example, we've connected a 600+ meter fiber for testing. A curve that drops downward after the starting point and remains very flat like this indicates a normal test result. What happens if the connector is contaminated or has poor contact? Now, let's first make the connector uncoupled properly and conduct a test to see the result. You can see that there is an obvious tailing at the end of the curve now. A curve with an arc like this is not a normal result. For a normal result, the optical fiber should be connected properly to ensure good coupling before the test is performed. Now, the curve we see has a shape close to a right angle. This is a correct test result. Only then can we analyze the curve accurately. Most users get fiber coupling right, but a common mistake is skipping fiber interface cleaning. Always clean both the fiber and instrument interfaces before testing. It avoids lots of problems.